Continue, and now we should add the planet map, Roma and cities maps to our new data frame projected. Let's add them. So here is cities, planet map, and Roma. We can add them all over the place. We have two cities now. So now see that now we can see the world map with cities. We can change, we have two Romas here, so okay, we can change it to the green color. See, it's Roma cities, our planet map, and Finland as well. We can also change the map of Finland, but we cannot see here because it's on the bottom. We can delete it. Okay. So the coordinate system of our data frame is Mercator. So now measure the distance between Roma and Buenos Aires. Change the data frame projection to Robinson. Okay, now we can change the projection to Robinson. It's also in the world folder. So see that Robinson is different from Mercator. It mostly preserves distances between points, right? While Mercator, as you remember, preserves shape and just direction. So measure the at first we should measure the distance between Roma and shape in Mercator, but never mind, we can do the same thing. So let's first open cities, and we should find Buenos Aires. At first here is the name, so let's sort in order to find so here's our Buenos Aires, right? And here's our Roma. So in order to measure, we should take this measure tool and see, we can make it closer. Here's our city, and we also can use this pan tool, right? Okay. So click it twice. Here is the distance between Roma and Buenos Aires in Robinson, while now we should measure the same distance between Roma and Buenos Aires in Mercator. Okay, let's do it again using measure tool. See that the difference already, the distance is 12 million 12 millimeters, while here's 10 million. So the difference is approximately 2 million. Which one is closer? The Robinson is closer because it preserves mostly distances between points, right? While Mercator, as you remember, preserves shape of the country and direction. So for this exercise, you need data frames Mercator, equivalent, and equidistance. Each data frame contains a world map with different projections, the location of Roma building, and the location of the world's largest cities. When you retrieve area information, make sure you use the F area field. So let's start. Let's start our exercise. So first activate data frame Mercator. So let's prepare it, right? We can use the same planet map, right? It's because our data frame coordinate system in Mercator. And now also we should add cities. So write down in findings. So we should measure the distance between Johannesburg and Roma, Sao Paulo and Jakarta, and also we should find the area of Russia and Zaire, and write our findings in this table. So let's first measure the distance between Roma and Johannesburg. First go to cities, the attribute table. Johannesburg, it's here. It's in South Africa. So let's first measure distance between Johannesburg and double click. So this is almost more than 8 million meters. So, and difference between distance between Buenos Aires and Jakarta. So in this case we have two records from this dataset, cities. So between Buenos Aires and Jakarta. So Buenos Aires is on the top and Jakarta is here, right? So second time use click Control button to select two records. So now here our cities, and we can measure the distance between them. See the big difference, big distance between them. And now we should measure area of Zaire and area of Russia and area of the whole world. So in this case we need this world Mercator, and we should find Zaire and Russia. So here Russia, here is the area of Russia in Mercator. Sorry, this one is. And now we should find Zaire. Zaire, here is the area of Zaire, right? And the total area of world, we can use statistics. Right click, statistics. The total area of world in Mercator is this one. And do the same thing to equidistant and equivalent. So we should first activate distance and area, right? So it's distant and area. So I pause the video here and just measure the distances and areas. So I finished just measuring distance between Rome and Johannesburg, Buenos Aires and Jakarta. I also measured the area of Zaire, Russia, and the whole territory of world. So in Mercator, distance and area data frames, which have different map projections. So the distance have the equidistant, see, world equidistant projection, and area has the world equal area projection. So now we can compare them with the actual true numbers with true distance and area. So Rome and Johannesburg see that this distance is closer to actual distance as the same, while distance between Buenos Aires and Jakarta, Mercator and area have the closer distances. It's because these two cities are located near the equator, therefore the distance that map projection has bigger distortions. The area of Zaire close to in Mercator and in equal area, which is not surprisingly. Area of Russia is close to again in distance and in equal area. See, that's almost more than 7 million square kilometers. And area of world close to, of course, in equal area. Also equidistant shows also a little bit more closer compared to Mercator. See, the Mercator is very huge difference with the actual numbers, 148 million square kilometers. So you should have the same or almost close